Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan sits down with Jennifer Li and Matt Bornstein, who are the co-authors of a seminal piece, Emerging Architectures for Modern Data Infrastructure, along with Martin Casado. Jennifer and Matt are both partners at Andreessen Horowitz, and they spend a lot of time thinking about how the ecosystem of tools is growing and what needs these tools fulfill for their users. What is so striking to me about the ecosystem is how fragmented it is and how different the toolkit is for data analysts and machine learning engineers, even when the underlying data is often the same. Tristan, what did you speak about with Jennifer and Matt, and who is this episode best for?
Who is it best for? This conversation is relevant to anybody who wants to know where the tooling ecosystem is going 2 to 5 years from now. It was a great conversation. Jennifer and Matt are always so incredibly knowledgeable on this topic. There were a couple parts of it that are particularly areas where I am curious about. I'm very interested in open tabular formats, Hudi, Iceberg, Delta, and what that means for the future of the compute layers that are implemented on top of them. We get into that towards the end of the episode. It's the age-old question, you mentioned it. Are there going to be more common threads between analyst workflows and data science ML workflows? And VCs tend to be very hard to pin down on these things. I tried to get an authoritative answer out of both Matt and Jennifer, but I think, honestly, it's a question that no one really knows the answer to. We are starting to see some more connective tissue appear, but to be determined how close these worlds are going to come.
Yeah, I think it's funny because Jennifer mostly does a lot of the modern data stack for data analysts, and Matt does a lot of investments for ML, machine learning, and some of the deeper data science workflows. And so they often study very different types of companies and how they evolve. And so it's even their practice is segmented and split up between these two different workflows. And I'm hopeful. I think that we will have to have better connective tissue between those two handoffs because the underlying data assets are the same. So I'm glad you got into that a bit on this episode as well. And without further ado, let's get into it.
I'm ready.
Jennifer, Matt, thanks for joining us.
Thank you for having us.
Thank you. This is exciting.
We are here to talk about a post that you wrote. It's an update of a post that the two of you wrote in, I think it was 2020. And it had, I think, at the time, the most complicated architecture diagram of modern data infrastructure that I had ever seen. And it also had this big, long list of names of people that you had spoken to in researching this. Can you talk a little bit about the process that went into that original post?
I take both great offense and great pleasure in the idea that this is the most complicated diagram you've ever seen, because it reflects the work that goes into it, and I think the complexity of the problem. So we spoke with probably 36 data founders, leaders of data teams, and sort of experts in this space that kind of hammered on all this stuff with us. We've also spoken to hundreds of data people over the years about these topics that really informed the work that we did. Our goal really was to produce something actionable, something people could actually use. Our view is basically, you can put as many logos on a page as you like, but it doesn't really help you build an actual data stack or really help you separate signal from noise, meaning what's important to pay attention to here versus what's, sort of the chaff. And so that's what we set out to do. And we really hammered through a lot of details with a lot of folks who know the space much better than us, and really just tried to channel, what people who actually do this day in and day out think are the most important things to be building.
As somebody that is in the position all the time of helping people make sense of this very fast moving landscape, it's nice to have that kind of a map. And it will provide a link in the show notes and to the 2020 post and the new post. But I think that what is so neat is not just that you listed some tools, it's that you actually drew arrows, and the arrows, I think, represent the data flow. Is that an accurate statement?
It definitely is representative of one way to think about it is data flow. The other way to think about it is the workflow itself as well, of how these tools are being linked together and the dependencies. And if anything, actually, making sure the arrows direction and connections are right probably takes half of the time than putting the boxes in together. And what I add on to Matt's comment is this is definitely years in the making to build this map where we have been consumers of a lot of content online about data, and we love the logo lists of companies and categories, but we really felt there is a vacuum of piecing the architecture and how practitioners think about how they are building data infrastructure. It is the missing piece in the market, and that's why we set on doing this and taking a practitioner view of if you want to build a modern data stack today, if you want to evaluate and use tools, what are the ways to piece a few technology together and build a coherent strategy around your use cases. And that's really the ethos of the piece.
I know the feeling of having written a piece that gets a lot of attention, and 6 months in, it's probably still feels pretty good. A year in, you're just like, I think that's maybe starting to show its age a little bit, but mostly it's still correct. And then 2 years in, you're just like, people are still looking at this. They're still like sending me emails. And you probably were tired of fielding all of these requests where you were just like, yeah, you're right. This thing is 2 years old now. Was this the impetus for like writing the update?
I think this applies to life in general. Like we all look back at our like former younger selves and think like, oh, how could I have said that? How could I have like worn those weird looking clothes and all that kind of stuff? It's like 3 years ago, me like really didn't understand anything. But you're exactly right. In this case, the data ecosystem is just changing so quickly. It's really pretty unprecedented. For a space that really didn't see a lot of fundamental innovation for decades. Really, I mean, we had databases, right? And we had, columnar database, right? We had slightly different kinds of databases, and we had ETL, and we had BI, and there really wasn't a lot new going on for a very long time. Even the Apache sort of open source movement, I would argue, had a relatively, kind of deliberate cadence built into it, right? Because you needed to invent something amazing at some big company. You needed to figure out how to open source it. You needed to coordinate hundreds of people to kind of work on this together. And only then could you really figure out how to get it into everyone else's hands. That feedback loop is really shortened pretty massively, where new companies, new ideas, new technologies pop up seemingly overnight. So in the intervening year and a half between publishing the two versions of our post, some things in sort of the core of the stack stayed the same and really kind of got stronger and grew. But a lot of the stuff sort of around the edges of the supporting technologies, they're brand new things that didn't exist a year ago, which is really pretty remarkable.
I want to come back to what's the same and what's different, but you mentioned something that has been bugging me recently. I think that for those of us in the space, we're all aware that there is this like massive acceleration in venture capital investment and company formation and all this stuff. But you mentioned the Apache ecosystem. I have gotten the sense recently that is growing at a much faster rate than I had been aware of. Like back in 2015, I feel like I could have just listed all of the data-oriented Apache projects off the top of my head. And now many projects come up in conversation that I had not heard of previously. In the process of researching this piece, did you come across, is that world accelerating too?
It definitely is accelerating. And we also entertained the idea 2 years ago of whether we include just Apache map on its own around data. So it is an observation that's very accurate, reflecting, both on both sides of these commercial products and also open source wise, how much movement and excitement there is.
I think there's a lot more diversity too, right? Organizations like Apache used to be kind of the only shop in town if you wanted to sort of develop a sort of well-governed, well-functioning open source project. And now there are not only other foundations, but people are just sort of doing it themselves in a really very effective ways. GBT is a great example of that. But there are a lot more kind of patterns and groups of people and ways to do open source that we're really seeing that kind of explode as well.
Topic for another conversation. Okay, so you mentioned before, there's a lot that has changed in the last 2 years. There's a lot that has stayed the same. Maybe we can start on, I think you called it the unified data infrastructure. So this is like the more analytics side of the world. The diagram that you've drawn there is essentially a more fleshed out version of a diagram that I think most of us have seen before. Data sources, ingestion, storage, query processing, transformation, analysis, and other output. The thing that I think that many practitioners, and this is something I've become more familiar with recently, but many folks might not be as familiar with, is the split between storage and query processing. Even though you find companies like Snowflake that talk about the separation of storage and compute, Snowflake is a unified product that does both. But your diagram highlights the fact that those two things no longer need to be packaged up together.
Yeah, so I have a really strong point of view on this. The fundamental principle here is that data is a measurement of the real world, right? Like if you think of Drew's keynote from last year, you go back to the very early uses of numbers, right? It's all about trying to understand the world around us. It's lengths and widths, and distances and weights and all this kind of stuff. If you believe that premise, then that means anything we do with our data is highly, highly complicated across many different use cases, all sorts of weird edge cases that you're never going to think of in advance and so forth. This comes up a lot in machine learning worlds that we do a lot of thinking about. One implication of that in analytics world, though, is you actually likely need different systems to do different things with your data. And I think that's sort of what we're seeing take place now. The data warehouse, historically has been an incredibly powerful tool and system of record. And it arguably still is, the leading technology to do both storage and querying. But you're seeing a huge proliferation of other things like Spark and Databricks, like these distributed query engines like Presto, real-time analytics like Druid or ClickHouse. Stream processing is sort of making a comeback or kind of making a go of it for the first time, depending on your perspective. And in order for all of this to work, and for companies, especially large companies, but sophisticated data teams in general, to take advantage of all these different systems and kind of process all their data in the ways that's really demanded, if you think you can actually model and understand the real world. The separation of storage and compute helps you do that, because you don't need to make your storage layer more complex in order to take advantage of all these new ways of doing things. You're right that it's quite different from the way Snowflake does it. Snowflake separates storage and compute at a technical level, because there are lots of benefits to doing that around cost and scaling and so forth. But they do not separate it at a sort of a business level or at a product level, which is fine, but it's solving for a different problem.
Yeah, I think taking a technology view, Matt's point is absolutely right. It's on the technical end, we see the separation and architectural shift of separating storage and compute. But I think if you take a practitioner view, this is really a reflection of how people are thinking about processing their data. It used to be very much tied to where the data resides, and you have these limitations, constraints of where you can process it, because the data is residing either on-prem or in customer's data warehouse that's not centralized or easy to access. And now, given, data is sparse around, your internal database, data warehouse, sometimes you bring in third-party data, sometimes it's meshing with customer clients' data, like the needs or the usage of data is very different. And practitioners tend to take a view of what are the use cases I'm trying to drive, and not tied to where the data resides, and think about processing and querying to fit in that needs, whether it's machine learning, whether it's analytics, whether it's building applications. And that in turn lead to what you see on the most right of the box, where the analytics and output column is way more comprehensive than years ago. It's more about dashboarding and building data, building graphics and charts.
That's interesting. And I want to go there. I also see a tremendous amount of new innovation happening on that column. But can you just give a quick overview of what is happening inside of file formats and table formats? And what are the names of things that people should be aware of there?
The movement here is to apply many of the benefits and guarantees you get from a data warehouse to unstructured data stores. And the reason that's a good idea is that people have realized, hey, something like Snowflake or BigQuery, offers a lot of really nice things to SQL users, right? You have transactions, you have consistency, guarantees in a certain sense. You have low latency performance. You don't need to worry about how your files are being, reshuffled or compacted, behind the scenes. So the theme is trying to bring many of those same benefits to just sort of arbitrary object or block storage. The projects that we think are interesting are Delta, which is a Databricks sponsored project, Apache Iceberg, which was developed at Netflix and Apple, and Apache Hoodie, which was developed at Uber. They offer similar functionality in some sense. Many of those things I mentioned a minute ago. The hope is that for organizations and data teams, adopting these technologies at storage layer allows you to take advantage of a lot of those, kind of technologies built on top that we were talking about. So if I'm running, a Spark workload on top of Delta, just for example, a lot of those nice properties, sort of come with the platform, and I don't need to reinvent the wheel, especially for folks building on things like Presto and Dremio and some of these distributed SQL engines. They're really used to having a lot of these nice features built into SQL. So having a storage layer with some of those additional technologies really, makes those systems behave more in the way that SQL analysts would expect. Without getting too deep into the details, essentially what these are table formats. So it's not changing the storage layer itself, which is say S3 or some other object store. It's not even changing the file format built on top of S3, which is often Parquet or one of these other, ways that we've managed to squeeze tables into object store. It's adding an additional layer of abstraction on top of that. It just makes these files and these tables behave in much smarter, more predictable ways. So a lot of the theory here is taking what's good about databases and data warehouses and making it sort of more open and accessible to all these new systems.
Let me just make sure that I'm saying this right. I think that the goal here is for you to say, okay, I actually want to be able to put ClickHouse and Databricks on top of this common set of data. And they're both operating on it, but because they have very different characteristics of what they are capable of, I get two options for reading and writing the same data. Is that right?
Yes, that's exactly right. And I wouldn't claim it's a solved problem. There's a lot of work that still needs to happen here in figuring out the right way to manage and consume these systems. But that's exactly the goal. That if I had different applications that require different underlying system performance, for example, if I'm using Databricks or Spark, I may have massive data sets that I need to process in pretty, bespoke ways. That's, sort of a common Databricks use case versus if I'm developing analytics application, for instance, I happen to know Roblox has hundreds of thousands, if not millions of developers on their platform, and they have to show dashboards to each of their developers to show them, here's how your game's performing, here's where users are sort of dropping out of onboarding flow, all this kind of stuff. That needs to be highly performant, low latency, user facing. It's a totally different set of performance characteristics. And for that, you may use something like a ClickHouse or a Druid or Rockset, something that has this sort of low latency characteristic to it. But you don't want to have to stick those two systems in two different silos because the data that they're operating off of, if not the same, is at least related. And, you can get a lot of benefits if that data is sort of the data in one system's aware of the data in another. So you're exactly right. If you can standardize where that data is being stored to the greatest extent possible, but use it to serve, applications and systems with different requirements, this is really a way of making it possible.
That's exciting. I want that.
We all want to live in a real-time world, I think, no matter how hard it is.
Yeah. Let's move on from unified architecture and then go into ML and AI. So I get the sense, and you please correct me if I'm wrong, but I think you had similar diagrams in your 2020 post and your 2022 post. You separated out analytics and ML and AI in both. And the thing that seems to have happened in the ensuing 2 years is that ML and AI actually diverged. There's more shift away from this kind of like analytics stack? Maybe that's increased capabilities. What do you think is going on there? Are we seeing these two icebergs like slowly start to float away from each other? And is there any chance that they will start to float back towards each other again?
Before I get really deep into like the nerdy stuff going on in machine learning land, I really want to know what Jennifer thinks of this, because she's the one who's always trying to keep me honest of like what people actually sort of care about and what it means to be an analyst versus a machine learning person. So I really want to know what Jennifer thinks about this.
I'm actually very, very curious why, Tristan, you said that the two icebergs are floating away from each other. From my point of view and talking to either data product builders as well as data analysts, data scientists, I feel the icebergs, if they're not closer, they're still the same relevance distance to each other. And we see more use cases bleeding actually between analytics and ML. One thing I agree with is the complexity of ML stack being more complicated is because for the advanced use cases, there are higher and complex requirements happening, which is driving either individual boxes becoming bigger or like these diagram becomes a little more complex. But in the intersection with the analytics stack, I definitely see a lot more interesting things happening to try to bring these two workflows together and try to have an even more smoother workflow when you're transitioning from building analytics dashboards, analytics app, plus models trained on top of the same table.
Got it. Okay. I love to hear that because it just seems logically like that is the way that this should move. Like we don't actually need to have 100% completely separate infrastructure to do these two different use cases. I'm not a person who spends most of my time or has ever spent most of my time in the ML world. And I look at this diagram and okay, so like you have a box that says compiler. And then it says under it, two example tools, OctoML and TVM. And I know that I am just sharing what a novice I am in this world, but like I've never heard of either of those things before. So I'm curious, can you just give us a sense of like, where are the areas in the ML diagram that are moving the fastest?
It's a really interesting question. And it sort of gets to your last point a little bit too. I would argue that the analytics ecosystem is much more mature than the machine learning ecosystem right now, which is one reason you see so much going on in machine learning. The workflows are really not nailed down yet in machine learning. I think there's sort of an existential debate going on whether machine learning is a product or a process, if that makes sense. Like if you take the product view, then you think, there's some way we can package up machine learning technologies into some sort of SaaS app and, sell the capabilities to people in sort of a prepackaged way. If you take the process view, you would basically say machine learning is coding of sort of a different sort. So there's no way to really draw a box around it. Like most companies will probably need machine learning teams in that view and really do the work themselves in a kind of pretty unique way to their business requirements and their business logic. So there's this really interesting sort of thing going on. And until that's resolved in some sense, I think you're going to see just like everything that may make sense, people are trying and putting all these tools out there.
This is like at the bottom of your diagram, there's this arrow going to a huge box that says low code ML. And then the other arrow comes at the other side and it's like, and so there are these tools that like kind of skip the whole stack thing. And they're just like, nope, just do this. And it's everything.
That's a perfect example, right? You can buy 5 tools if you want to do things in the really sophisticated way in the ML world. Or you could buy 1 tool if you think the sort of low code version is good enough. Or in the really extreme version, you can go to Salesforce and say like, hey, you do lead scoring for me. I want 0 tools to do it. I just want it to be built into my CRM. So all that is sort of going on. And, if you're a maximalist, to borrow the sort of, Web3 term, it's, you probably think everything's going to happen. Like all these things are going to become, durable and really important parts of the machine learning world. If you believe machine learning is an important thing, which I personally do. And it gets back to this idea that, data is sort of an attempt to measure the real world. And this is a way that we can help, we can try and understand it. Low code in particular is very interesting there are a number of interesting companies and this new companies, startups in the space, like Continual AI is an interesting one. There's one called Akio, MindsDB, which is sort of a database integration play. And, what they're all trying to do is sort of nail the workflow that makes machine learning more accessible to more people. And you may not be able to use these tools to do really kind of hardcore in-product, what they call sort of online real-time machine learning. That's like,
you're not going to use it to do routing for your Uber algorithm.
Exactly. That's a perfect example. Or when you open the Uber app, the arrival time that it shows, that's a machine learning model, for instance. And so you wouldn't use a low-code ML tool yet, at least to do something like that, which is pretty bespoke and has pretty intense requirements. But for an ordinary analyst who's just trying to do lead scoring, there are a lot of really great tools now that you can use. SQL primarily, you can use some Python or even just call some REST APIs and get like a pretty, accurate model that does a lot of what you would need. Using fairly standard, what are called sort of boosted trees or other kind of traditional machine learning models that are really good enough for the vast majority of these kind of analytic use cases.
Yeah, going back to your question, Tristan, that's exactly where Matt is painting. Where we see the most movements is actually bifurcated around very sophisticated use cases that processing a large amount of data bespoke to companies like Uber, like Airbnb, like Netflix, that's writing a ton of recommendation algorithms, as well as more real-time applications. That's a set of tools being adopted to enable that large-scale data processing and model training. And the other side is actually where we see a ton of excitement and movements is the pieces that ties very closely to the analytics world, whether it's query engine, whether it's metrics layer, whether it's workflow orchestrator, like the smoothing out the workflow between data teams that processing analytical batch data and merge it with some real-time models or even also one-off models to predict a price or revenue. So those two workflows is where we see a lot of excitement, where I think that the little bit of depth of value, which I call it's sort of this no man's land where you're trying to do complex tooling for like not very well equipped team to like fully invest it into like building machine learning functionalities for the applications that they're trying to do. So I think that's where we see less excitement and movements.
You mentioned Continual. I'm very excited about them. They're using DBT artifacts as places to save information about models that you'd like to build. And then so it like shows up in a way that's kind of perfect for somebody like me. And then it handles a part of the downstream work that somebody like me is probably the least ready to take on. Like I can tell you what inputs, what features I want for my lead scoring model to keep with that example, but I'm probably not that well positioned to like maintain that model in production. And so I think that it is very exciting, the idea that we as analytics engineers are going to get more superpowers as these tools continue to develop. In the ML and AI, you kind of referenced this, Jennifer. There's probably some of these boxes that an appreciable number of companies who are involved in doing this work at all, that probably everybody has some type of workflow manager. They've got Airflow or Prefect or Dexter or something. But there's probably some of these other categories that are not that widely used yet, and only the most forward-thinking companies. Do you have any sense of like, what are the like really bleeding edge categories here that only the Ubers and Airbnbs, et cetera, of the world are using?
So I have a really favorite one in this thing that I'd love to talk about. Andrej Karpathy gave this amazing talk a few years ago on the different types of stop signs in the world. And it sounds like the most boring thing you could possibly imagine, right? Like you've never, like how many miles have you driven? You've never even thought about what your stop sign might look like. But literally he ran through, it must have been 100 examples of, there are two-way stops, there are four-way stops, there are stop signs attached to school buses, and stop signs attached to bars that come down over the road like this to stop you from getting hit by a train. And there's, things that should be yields or merges that are also, so literally there are way more than you think. And what's so interesting about this is they built this system at Tesla that automatically generates weird examples of data for them. So they've got however many Tesla cars they have out on the road. They all have cameras attached to them. And Tesla is able to not only consume those video feeds, but identify things that are interesting in those video feeds from a machine learning point of view, so that they can better train their self-driving feature. And that's a really hard problem, right? If you have, literally billions of hours of video to try to, parse through and figure out.
Show me the weird stuff.
Yeah, exactly. Is where's my model working? Where's it failing? And where's just the plain weird stuff that we never could have anticipated before we put, all these self-driving systems out there. And what they built was a system that sort of automatically identifies. So if you're interested in stop signs, it goes out and finds a million different types of stop signs for you, puts it into a flow where engineers can kind of see what that data looks like, integrate into their training process, and then ultimately retrain the models to make them better. So you get this sort of loop, sort of a feedback loop where you develop the machine learning model, you get it out and deployed, you have sort of a data collection mechanism that's figuring out how it's working, how it's not working, and then using the outputs of that to make the models better and then, sort of continually improve. This is kind of the holy grail that people have always wanted in machine learning, this kind of continual learning model. And Tesla has it, and they've been talking publicly about it, and now everybody else wants it. So you're seeing a bunch of new startups essentially trying to replicate that in some form. The key question is, how does it plug into the rest of the workflow? And again, like, if most companies don't understand their own ML workflow yet, how easy is it to sort of plug into it? But it's something I'm very excited about, because it sort of can deliver on this idea that, like, machine learning is actually getting better and better over time, and plus it's just cool, right? If you're a connoisseur of, weird stop signs, it's just kind of fun stuff.
Yeah. My answer to that is, what is cutting edge? I believe every time when we start talking about a term like reinforcement learning, like deep learning, it actually starts getting mainstream like 4 or 5 years later. Like, probably a lot of the conversations started 4 or 5 years ago, but the real applications and the real use cases only started emerging now. So one of my favorite examples is actually Ray, and this it's in this distributed processing box or layer, where you can actually, it's very magical. You add a few lines of Python, and the whole processing it's parallelized, and in the performance improvements, it's really night and day difference. And again, it is something that really it's needed for processing large amount of data for reinforcement learning, and that's where the best use case is today. But you can definitely see a future where this is being generalized for a lot more machine learning workloads or other large scale data workloads.
I love that, and I've looked at the demos for. I think that there's a couple of other projects that are pursuing a similar approach. You look at the demos and they all feel they all feel like very magical. And one day I need to dive under the covers a little bit more to understand what the heck is going on there. Because, I mean, honestly, one of the most challenging things about Spark for me as a user is that, like, you actually have to write your code differently. So there's like this whole learning experience. But if you could just write a different import statement, that's extremely compelling. Okay, so towards the end of your post, you get to maybe what could be the most controversial part of it. And you didn't actually kind of drop the mic and say, like, everything's going to be bundled. But there's this ongoing conversation about bundling and unbundling. And it's not lost on anybody that when you look at this diagram, like, that's a crap load of tools to purchase. Or even if they're all open source, it's like a lot of tools to stitch together. So you, at the bottom of the post, you introduced this idea of a data platform. And maybe that's not exactly the same thing as like bundling or M&A or anything like that. But there is some level of, like, there's some consolidation going on there. Can one of the two of you, will you mind walking me through what you mean when you say data platform, and are you taking a stance? Is this happening?
I thought we successfully dodged the bundling and unbundling question by calling it a data platform.
Yeah, this is so dangerous. You should count the number of times we said might or may or could be.
Right.
Jennifer, do you want to start on this one, and I can go next?
Well, I think the point, or at least the question we want people to think about with a data platform is what it means to bring the analytics world to data applications together. And that's what this picture of data platform is trying to paint is you have this very mature ecosystem now for analytical data workloads, and there is a lot of requirements and demand for building data applications. And what is the future look like that's really bring these two use cases together? And whether it's unbundled or unbundled, probably in the near term, we'll still see more tools coming up to enable that future. And there's a lot of conversations around what it means for OLAP databases and transactional databases to work together more seamlessly so that developer experience is much better than having, data team build tables in one way and have to bring data in from transactional data store, that whole workflow, what it means to the end user. So that's the core ethos of how we're thinking about data platforms, is trying to paint sort of a future of what it could mean or it could be when the emergence of data apps being built. There are a couple ways of either tying the transactional data to analytical data store, or the other way around by exposing APIs to access these tables.
Yeah, and so I think that's exactly right. We're trying to set the question in a way. Bundling versus unbundling is, I think, a tough thing to talk about, and people much smarter than us have shared a lot of interesting opinions about it. I think, for instance, Ben Stansel has some of the most interesting takes, and everybody should read what he says. But what's interesting is the technologies and the products that you see in the data stack right now are most likely a reflection of the actual need for what people need to do with their data, right? Like if you just look at tech categories historically, where you get this huge profusion of vendors and products is where the need is really the greatest. Like cybersecurity is a great example. Like if you think the data stack is ugly, you should see a cybersecurity, market map. And for every tiny little problem that anybody's ever had, there are 5 companies that address that tiny problem in particular. And security buyers are constantly trying to consolidate their vendors together because they're sick of buying from so many people at the same time. And they would like the world to look different. But the reality is those tiny problems are not actually tiny, right? Like somebody at some point in history has had a massive security issue because of each one of these little problems that, they had a hole in their, upstream software supplier or some, a vulnerability in their upstream software supplier or something like that. So whether we as practitioners or as investors or as founders want everything to consolidate together or not, bundle together or not, may not have a huge impact on whether it actually does, which is sort of counterintuitive, right? Because you would think like the customer is always right and whoever's implementing these systems should really have the final say. But if it may not be up to them, if the problem to be solved is such that you just actually need all these tools. And you may see vendors consolidate, right? You may see one company buy another, and that happens all the time. And that helps from a finance and sort of a business standpoint because you have to deal with fewer vendors, billing's easier. They may talk to each other a little bit better, that sort of thing. But that's unlikely to fundamentally change the products that we're using, right? Like it would be unusual if one big data company bought another big data company, that the actual product experience would change. More likely you would continue to use both those products because they proved to be important and, they have big user bases and businesses behind them.
You talk about platforms, and for me, I always think about iOS and Android. I think about Windows. The thing that feels important to me here is that your application that works on iOS doesn't just natively work on Android. There's a certain level of platform lock-in. You have to build your application using the proprietary APIs of the underlying ecosystem. And I think that maybe at least a little bit we're protected in the data space by SQL, because SQL is at least largely standardized. Now, it's not perfect. There's a ton of extensions on every platform, and you obviously can't take something that runs on BigQuery and just drop it down and run it on Snowflake and have it work perfectly, but we're at least a little bit protected there. So I think a part of the platform evolution question is, do these huge data platforms try to expose APIs that are fundamentally not SQL and that they are actually like very different from, if Snowflake and Databricks both released a way to sell in their marketplace and you got functionality that you wouldn't get access to otherwise. And they started this like bifurcation. I'm building a Snowflake BI tool that somehow fundamentally is different than a Databricks BI tool, which like perish the thought. That is not the world that I want to live in. But is that kind of the way that you're thinking about what a platform is too?
Yeah. So, okay, first I'll say what is not a platform? Like if you Google data platform, you'll get a bunch of big companies trying to sell you a bunch of stuff. And they say, hey, a data platform is whatever we want to sell you. And like, oh, by the way, good news. The more stuff you buy from us, the more platformy it gets. Right. So, like crack open your wallet. It's like, that's not a data platform. What we see as a platform, as you rightly pointed out, Tristan.
But like Docker is also not a platform, right? Docker is a standard.
Totally agree.
Definitely.
But it's not a platform.
I think you're totally right. And so there are sort of two aspects to a platform. One is technical, which is this is something I can build an application on, right? And Windows and iOS and all these things certainly meet that criterion. I'm trying to think now whether Docker meets the criterion of you can build an application on top of it. I don't know if you can. That'd be an interesting question, but there's a sort of technical aspect of you can build an application on it. And then there's a sort of business aspect of you get distribution by building on top of it.
Yep.
And that's sort of the Windows, Apple or, Microsoft Apple thing is, their platforms are not fundamentally different, right? I can write an application for Windows or for Mac or for iPhone or Android or whatever. But they're each their sort of little ecosystem where I think users are going to show up and actually use the thing I built. I don't know whether SQL protects us or not. It's a really interesting question because you could use similar programming languages to write software for different, device targets, for instance. But it's really the underlying capabilities of those devices, the sort of operational aspects and the ecosystem that's been built around it that makes it kind of a platform and gets this sort of platform flywheel going. I think we're going to see that for Snowflake, just reading the tea leaves from the outside a little bit, right? They're building a lot of interesting functionality to help people do that. Companies like Databricks have arguably done that for a while already. Their sort of reason for existence in many ways is to enable applications. So, and these guys will continue to add new capabilities, reducing the latency of their systems, increasing throughput, increasing availability, making it easier to deploy. And, many of those things I think will be harder to replicate. If data warehouse X that's not Snowflake wants to add all that same functionality, it's definitely not in the SQL spec. They may be able to do it, they may not be able to, but it's probably not going to look exactly the same. I don't want to predict the future, but those are some of the interesting things we're tracking, at least.
Sure. This has been a lot of fun. Thanks for joining us. I want to wrap up with a question that we always ask, but maybe I'll ask a slightly customized version for you two. You've now done this twice. Let's say that you release a third one of these in another 2 or 3 years. Not what do you think will be true or different, but what do you hope will be different about that post?
As I mentioned, I think this data platform concept and bring the analytical workload closer to operational and the other way around as well. It's more becoming more of a reality and more widely adopted. And this, whether it is through either bundled or unbundled data platforms, I think that is just a better future for data producers and consumers to build interesting products and have data enable a lot of the either automation or insights that we hope to have as soon as possible. So that is a future I would love to see happens down the road. And it could mean more easy to use developer tools. It could mean like more interesting processing layer that enables that. And again, I do feel like a lot of the workflow side for data engineers and analytics and engineers can continue to improve to enable that future.
Matt?
Man, this is a hard question. I think a lot of what we've talked about today has to do with data people, whether they're analysts or analytics engineers or machine learning engineers or data scientists, kind of finding this sweet spot of highly expressive languages and systems that are also easy to use and have like no operational burden. The infra kind of comes for free, and it takes a bunch of different, it's like SQL, it's really powerful, which is sort of like what dbt and Snowflake can provide, or it could be like Python or Java that's really easy to use and really easy to get up and scale. That's kind of my hope for the data ecosystem, that we see those things start to converge, and it's like, man, whatever job I have to do and whatever like language and ecosystem, whatever I like to live in, I've got amazing tools to kind of do that in a, what I like to call sort of like medium code or kind of pro code way, where it's like the full technical capabilities of these systems are open to me, but like I don't need to be like a level 7, like Google engineer to know how to do it. Like that's kind of what gets me really excited, and that I hope we see a lot of these systems start to reflect that.
Yeah, and just to add on to both of our thoughts, I would hope, I don't know if it's going to happen in 2 years, that this diagram becomes a lot simpler. So we won't be bombarded or pinged about where the
Matt shaking his head. He doesn't see that.
Yeah, that I will unfortunately take the other side of that bet. I just think like these things only move in one direction, and it's good. It's good for all of us, because it helps us jump jobs much better in all this.
Yeah, I don't think it's going to happen either, but we can hope.
Where can listeners find out more from both of you?
Can follow us on Twitter or reach out to our official account or our emails. That's our initial and last name. So anyways, we're pretty much everywhere in dbt Slack as well and we love to geek out about data.
Awesome. Thank you both.
All right. Thank you so much for having us, Tristan. This was awesome.
Thanks, Tristan.
The Analytics Engineering Podcast is sponsored by dbt Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.